The question is like this. So we have 10 gram of ice. So there is a beaker. And this beaker contains 30 gram of water. 30 gram of water. And 10 gram of ice is added to the beaker. And the ice is at 0 degrees Celsius. And CV of water is given to be 1. And latent heat is given 80 in units. This is 80 calorie per gram. Calorie per gram. And this CV is 1. So what will be the unit? Q is equal to mc delta T. So C will be joule. That means calorie per gram per degree Celsius. Okay. So it is calorie per gram per degree Celsius. Okay. So you have to tell the final temperature. Final temperature when it comes to thermal equilibrium. When it comes to thermal equilibrium. Okay. So now if nothing is given, that heat is lost in the atmosphere or through the beaker or something else, so you will consider that only this thing is happening. Are you getting the point? Don't consider it as a system, I mean some natural system or some a system in your room, that there is a beaker, there is a water, you are putting some ice. Don't think like that. So we have to consider it to be very, very ideal, okay? Not actual. That is what I meant. So what is going to happen? You have a 30 degree of water, so 10 gram of ice. So when you mix ice to the water, what will happen? The first thing is that how the common temperature will be reached. So here 30 gram of water was at what temperature? 25 degrees Celsius. So please understand this. 10 gram of ice will require heat to melt. That will be Q is equal to ml, and that is 10 into 80. So 800 calorie heat is required to melt the ice. 800 calorie heat is required to melt the ice. 800 calorie heat is required to melt the ice. Okay.
Sir.
Now from where this heat is going to come? This is going to come through water. So how much heat this water can give? Water can give heat if it goes from 25 degrees Celsius to 0 degrees Celsius. Yes or no? So that heat is mc delta T, which is 30 into 1 into 25, which is 750 calorie. Okay. So you can see 800 calorie heat is required from the 10 gram of ice, and only 750 calorie can be given by the water if the water cools down to 0 degrees Celsius, which is the freezing point of the ice. So that means the total ice will not be melted, yes or no?
Yes, sir.
Yes, sir.
So that means some ice will remain.
Same.
So that means final temperature will be
0 degree.
0 degrees Celsius. So only mass that will be melted is m into 80 is equal to 750. Correct?
Yes, sir.
So what is mass that will be melted? 750 by 80. How much is this?
9.37.
9.37.
9.37
375.
gram. So that means 10 minus 9.37. What is this number?
0.625.
Hmm?
Yes, sir.
So 0.63 gram ice will not get melted. So obviously when ice is there, the temperature will be 0 degrees Celsius. Is that okay?
Yes, sir.
Everybody?
Yes, sir.
किसी को कुछ पूछना है? Let us do some more questions. Anybody wants to ask anything from this?
सर
Hmm.
सर ये जो वाटर 0 डिग्री सेल्सियस हो जाने के बाद आइस में कन्वर्ट नहीं हो जाएगा?
वाटर 0 डिग्री तक आएगा ना? जो
यस सर.
वाटर जो हीट दे सकता है वो तो सिर्फ डेल्टा टी ही दे सकता है ना?
यस सर.
तो वाटर 0 डिग्री तक आ जाएगा
यस सर.
और आइस उतनी हीट को लेके मेल्ट हो जाएगी.
यस सर.
लेकिन बिकॉज इतनी आइस अभी भी बची हुई है उस पानी में जिसका टेम्परेचर 0 डिग्री सेल्सियस है. सो दैट मीन्स जब तक कि वो पूरी बर्फ पिघल नहीं जाती, टेम्परेचर विल रिमेन 0 डिग्री सेल्सियस.
यस सर.
Unless that amount of ice is melt down, the temperature will remain 0 degree Celsius. Okay?
यस सर.
Okay. Let us do the next one. So there is a metal bullet and it hits a target. This is metal bullet. metal bullet hits the target and this metal bullet is moving with a speed of 80 meter per second. It hits the target and 50% of the heat that is generated remains in the bullet. Okay, 50% of the heat generated remains in bullet. Okay,
Yes, sir.
and what is the increase in temperature? So it is given that specific heat of the bullet is 160 joule per kg per degree Celsius. That is the specific heat it is given. And they are asking how much temperature will change. So see, the kinetic energy of the bullet will be half mv square, which is half into m into 80 into 80, right? This is the energy of the bullet. When it hits the target, 50% of the energy is remained in the form of heat. So heat in the bullet will be 1 by 4 into m into 80 into 80, correct? This
Yes,
will
sir.
be the heat there. And you know heat Q is equal to ms delta T. So that is 1 by 4 into m into 80 into 80 is equal to m into 160 into delta T. Correct? M and M will cancel. 2, 4 and this delta T will become 4 4 just 16. So that is 10. Yes?
Yes, sir.
10 degrees Celsius. See this question? Clear है सबको?
Yes, sir.
Is the question clear to
Sir?
everyone?
60 है सर वहाँ पे
Sorry?
116. Sir, 160 है sir,
Sorry.
1600.
nominated sir 160
116 हो sir.
सर
Hmm.
सर ये हीट 1/4 mv स्क्वायर कैसे
इस क्वांटिटी का आधा 50% of this quantity. How to calculate?
ओके सर बाय टेकिंग हाफ
Write it like this. Now it is okay?
ओके सर यस सर
सर चेंज इन टेम्परेचर किस चीज का पूछा गया है बुलेट का
बुलेट का.
ओके
Okay. So can I erase this?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Right. Next question. Ice of density ρ1 melts at pressure P and absolute temperature T to form water. So this is ice. To form water of density ρ2, the latent heat of melting of 1 gram of ice is L. This is latent heat. What is the change in internal energy resulting from melting of 1 gram of ice? This is the question. Shall I repeat?
Yes, sir.
Ice of density ρ1 melts at pressure P and absolute temperature capital T to form water of density ρ2. So this melts to form water of density ρ2. We have to calculate the change in internal energy resulting from melting of 1 gram of ice. Question is clear?
Yes, sir.
Yes, sir.
Yes?
सर लेटेंट हेड की वैल्यू दी है
L.
लेटेंट एल दी है
How much latent heat is given?
L.
L. So let us calculate. So how to get the change in internal energy? du is equal to, I mean
Minus PdV.
dq is equal to du plus pdv. So what is du? dq minus pdv. So du is ml, which is 1 into L, minus pdv. Are you getting it? Hello?
Yes, sir.
Yes, sir.
So density is going from ρ1 to ρ2. So we have to calculate this change. So density goes from ρ1 to ρ2. So what is density is equal to mass upon volume. So volume is 1 upon rho.
Yes, sir.
So what is dV?
Yes.
It is minus 1 by rho squared d rho, because you know in this case they are talking in terms of density. So we can't talk in terms of volume. We have to also switch towards density because they are talking in terms of density. Yes or no?
Yes, sir.
Yes, sir.
So du will become L minus P dV will become plus P d rho by rho square. Is that correct?
Yes, sir.
D rho by rho square. So if you calculate the change in internal energy from rho 1 to rho 2, so this delta U will become L plus minus actually minus P. This will be minus 1 by rho, na?
Yes, sir.
So minus 1 by rho means
1 by rho 2
1 by rho 1 minus 1 by rho 2.
sir, upper minus lower, right? Here.
From rho 1 to rho 2, na? Ha, rho 2 minus rho 1. Or it will become L plus P 1 by rho 1 minus 1 by rho 2. So internal energy will increase or decrease?
So rho 1 is bigger, na?
Yes.
So sir, it will decrease.
Delta U will be positive or negative?
It will increase.
No, you can't.
We can't say it's because
You can't say because delta U is P 1 by rho 1 minus 1 by rho 2, right? So rho 1 is greater.
Rho 1 less than rho 2.
सर आइस का डेंसिटी तो
कहाँ नहीं
वाटर
जा
से कम
सकता?
रहता है
आइस का कितना होता है?
सर वो तो पता नहीं लेकिन आइस तो वाटर
Water
को
से
फ्लोट
कम।
करता है
वाटर का अगर मैं वाटर की डेंसिटी कितनी दी हुई है rho 2 and ice is rho 1. So rho 1 is less than rho 2, na?
यस सर
So this quantity is positive, correct?
यस सर
So can I say that delta U is positive?
Yes, sir.
Delta U is greater than 0. एक बार numbers के term में भी देखना कि what are the values, okay? Somebody can see and quickly tell. I think कोई बात नहीं, देख लेना बाद में. So this question is okay? समझ आ गया?
सर सर ये जो स्टेप है डी यू इक्वल टू एल प्लस पी डी रो अपॉन रो स्क्वायर एंड इंटीग्रेट किया है हमने, है ना? तो
रुक जाओ, wait. Actually, this is okay, this side?
हाँ जी सर.
If you are missing this, I can write it like this: L minus P
इंटीग्रेट
1 by rho. Integrate कर दिया.
हाँ जी सर
And
अंडरस्टूड.
rho 1, rho 2.
सर आप हम बोथ साइड्स इंटीग्रेशन करेंगे ना?
अरे तो ये क्वांटिटी तो फिक्स ही है ना?
तो ये कांस्टेंट ही है ना?
ये तो कांस्टेंट ही है.
तो फिर अगर इसकी
जो चेंज
इंटीग्रेशन
निकाल रहे हो, डेल्टा यू जो निकाल रहे हो, वो तो बस इसको अलग से करना चाहिए. चाहो तो इस इक्वेशन में मत लिखो, जस्ट पी डीवी को अलग से मैनेज कर लो. Because whatever is here is fixed.
यस.
So this quantity only depends on this. So calculate it separately and put it if you are not, if you think that you have to do it like this.
हाँ जी यही सोच रही थी. ओके.
For integral, you should have d of something, na? This is a number. So that means this will remain constant, only this will be integrated. Okay.
सर वही वही तो अगर मतलब इसको हम इंटीग्रेशन में मतलब कंप्लीट इक्वेशन के अकॉर्डिंग लेंगे तो ये कांस्टेंट है इसकी, तो फिर उसके साथ किसके साथ विद रिस्पेक्ट टू इंटीग्रेट?
अरे नहीं होगा ना इंटीग्रेट, एक मिनट में बता रहा हूँ। जैसे भाई तुमने मान लो दिस चेंज इज इक्वल टू समथिंग माइनस दिस,
हाँ जी,
so this is a number,
हाँ जी,
fixed number, so this change will be this fixed number minus integral of
या ओके,
phi dv from v1 to v2, something like this. Okay.
हाँ जी।
So इससे जो सबसे पहले जो कराया था that was a previous year question of TIFR. Then what I did is previous year question of JEST, and again that the one I did is also previous year question of JEST. Okay. Just to give you a sense of what type of questions are asked. Is that okay?
Yes, sir.
Sir,
Little bit you will try and little bit I will discuss. Yes.
the 0.902 के अप्रोक्सीमेट आ रही वो न्यूमेरिक वैल्यू,
किसकी वैल्यू?
तो वो जो न्यूमेरिकल वैल्यू थी ना 1 माइनस रो 2 माइनस रो 1,
Oh, that is okay. That answer has to be put only in terms of row 1 and row 2,
जी सर,
not the numerical value. Okay.
यस सर,
So again, next question, we will have to write the full language. Otherwise, we can't do that. Okay. So write the language. An ideal fluid is subjected to a thermodynamic process described by rho is equal to C V to the power minus alpha. An ideal fluid is subjected to a thermodynamic process described by rho is equal to C V to the power minus alpha, and P is equal to N rho to the power gamma. Rho is energy density and P is pressure. Rho is energy density and P is pressure. For what values of N and gamma the process is adiabatic? If the volume is changed slowly. Question? Everybody has written it properly?
Yes, sir. Sir, here are two processes given.
An
Number one,
ideal fluid is subjected to a thermodynamic process described by this and this.
okay, sir. Yes, sir.
So process is one, they are described by these two equations,
Okay, sir.
where rho is energy density and P is pressure. For what values of N and gamma the process is adiabatic if the volume is changed slowly? Is that okay?
Yes,
So
sir.
the first thing is that we have to think about adiabatic process. And you know what is adiabatic process? dq is 0. Yes or no?
Yes, sir.
So the first equation is dq is equal to du plus energy density. So U by V is rho, and that is equal to CV to the power minus alpha. So that means U is CV to the power minus alpha plus 1. Am I right?
Yes, sir.
So what is du? It is C minus alpha plus 1 V to the power minus alpha and dV. Is this correct?
Yes, sir.
Yes, sir.
And if I talk about P, it will become dq is equal to C minus alpha plus 1 V minus alpha dV plus P. What is P? N
Rho to the power gamma.
U by V gamma
Yes, sir. Into dV.
into dV. And what is that? Means C 1 minus alpha V to the power minus alpha dV plus N. What is U by V? C V to the power minus alpha into gamma dV. Yes or no?
Yes, sir.
So this is equal to C 1 minus alpha plus N C power gamma V to the power minus alpha gamma and dV is equal to dq. Is that correct?
Yes, sir.
फर्स्ट टर्म में v माइनस v रेज टू माइनस अल्फा आएगा ना.
Yes. So is there something that can come common? What can come common? Tell me.
CV to the power minus alpha.
What?
c v रेज टू माइनस अल्फा एंड dv.
C
c v रेज टू माइनस अल्फा एंड dv
1 minus alpha plus N
c रेज टू gamma.
C raised to
Gamma minus.
gamma
Gamma.
minus
V raised
C gone na?
Yes,
So
sir.
gamma minus 1
And V to the power minus alpha gamma minus alpha.
V to the power minus alpha gamma minus
प्लस हो जाएगा शायद. प्लस हो जाएगा. डिवाइड कर रहे हैं ना.
V minus alpha is gone na?
Yes, sir. So then we
So
plus.
it will be plus this one. Correct?
Yes, sir.
So if you want the process to be adiabatic, that means this bracket should go to 0. Correct?
Yes, sir.
So what will be the value? V to the power, what it will become? Alpha 1 minus gamma.
Yes, sir.
So what happens? Tell me. To make this is equal to 0, what should I do? Gamma I should make 1, huh? So that this value will become 1,
Yes, sir.
and alpha I should make 1 minus n. Okay. So what we should make? We should make the value of gamma is equal to 1, and the value of alpha, how much? N plus 1, na?
Yes, sir.
Bas. So if we make it this, then dq will go to 0 and the process will become adiabatic. See, if gamma becomes 1, so power 0 will become 1. So this quantity will become n. So now put n plus alpha minus 1 is equal to 0. So you will get the value of alpha. So they wanted n, na? N and gamma. So what will be n? Alpha minus 1. Ask me if there is any doubt.
सर गामा कैसे 1 लिया है?
देखो, तुम्हें इस क्वांटिटी को 0 करना है, राइट?
यस सर.
तो अगर तुम गामा को 1 कर दो तो ये दोनों क्वांटिटी 1 हो जाएगी.
यस सर.
Then this will only become n.
यस सर.
Now put n plus alpha minus 1 is equal to 0. N plus alpha minus 1 is equal to 0. So you will get the value of n.
यस सर.
So मैंने गलत लिखा है.
सर हमने
n
assume कर
will be
लिया.
1 minus alpha. N will be 1 minus alpha. What?
सर ये तो हमने मतलब ये ऐसे नहीं मतलब कि हमने वो चीज लेके मतलब ये दोनों मतलब जैसे n इतनी होगी और ये इतना होगा तो ये इक्वेशन इक्वल टू 0 आएगी.
तो ये प्रोसेस एडियाबेटिक हो जाएगा.
हाँ जी.
यही पूछा था कि for what value of n and gamma the process was adiabatic. So 4 options were given. So the option in which alpha gamma is 1 and n is 1 minus alpha is the correct option. Okay.
Okay.
What you want to know? There is any confusion?
मेरा मतलब ये है कि अगर हम देखो गामा को मान ली सपोज करके 2 लेके चलते हैं तो भी ये तो n की तो कोई वैल्यू आ ही जाएगी, उससे ये वाली 0 तो हो ही नहीं रही.
इसका मतलब ये हुआ कि आपको मुझे ऐसे बता देना चाहिए था.
अगर मैं 2 लेके
No. Don't do that. I will tell you. Gamma is equal to alpha minus 1. N is 1. Gamma is 1 minus alpha. N is alpha. Gamma is 1. N is alpha minus 1. And gamma is alpha. N is 1 minus alpha. Now tell. These are the 4 options. Some questions are, you have to see the options also, no? What kind of
ओके मतलब
Yes, sir,
ऑप्शंस
see.
में गिवन है सो वी हैव ट्राइड दिस ठीक ठीक है सर
you can try otherwise also if somebody asks that how to go about it. So थोड़ा दिमाग लगा के कि because यहाँ भी गामा -1 है, यहाँ भी 1 माइनस गामा है, so I can put gamma is equal to 1. Okay, but otherwise once options are there, it is very clear that what you have to do.
ठीक है अब ऑप्शंस के अकॉर्डिंग तो ठीक है
नहीं वैसे भी ठीक है, वैसे भी what you can do.
तो वैसे वही तो मेरा क्वेश्चन है कि अगर हम 2 भी ले लेते हैं
तो फिर
तो
C भी
n
रहेगा,
की तो
V भी रहेगा.
तो n की तो कोई वैल्यू आ ही जाएगी
But
ना
that
CV के
will
साथ
not be like this, na? That will be in terms of C, V. I mean, you are not playing. You are playing with then V also. Volume factor will also be there.
ओके
Only in one case, volume will be gone.
ओके
Sir, n is equal to alpha minus 1 आएगा ना 1 minus
Sir, yeah.
Hmm.
So alpha
Equal
equals
to
to
alpha
n
minus
plus 1
one.
है तो n 1 alpha minus 1.
2 बार लिखा मैंने, दोनों बार गलत लिख दिया. N is equal to
Alpha minus 1.
minus
alpha minus 1.
1.
Can I erase this now?
Yes, sir.
So see, just simple manipulations are there from first law. So thoda agar, if you have little habit of working out things, then you can do it. No problem. Okay, let's do one more problem. Right? A theoretical model for a non-ideal gas. A theoretical model for a non-ideal gas gives a theoretical model of a non-ideal gas gives following expression for internal energy and pressure. So that means for some non-ideal gas, the internal energy is represented like this and pressure is represented like this, where A and B are constant. Let V naught and T naught be the initial volume and initial temperature. Let V naught and T naught be initial volume and initial temperature. If the gas expands adiabatically, volume of the gas is proportional to T to the power alpha alpha is equal to 1, 3/2, minus 3/2, and minus 2. This is the question. Okay. So this is the internal energy, this is the pressure, and we have to write the volume for adiabatic process. So let us write dq is equal to du plus pdv.
Yes, sir.
And for adiabatic process, we have to calculate what is going to happen. Okay. So for adiabatic process, what will happen? Du will become minus pdv. Yes or no?
Yes, sir.
So get du minus 2/3a v to the power
Minus 5/3.
minus 5/3 dv.
Sir, आगे भी. Yes, sir. Yes, sir.
Plus 2/3 b v to the power
minus 1/3
minus 1/3 dv into t square.
Yes, sir.
Sir, t square to t.
So basically du by dv will be minus p, na? Are you getting it? If you want me to write it like this, I can write it like this. Minus p is equal to du by dv. Yes or no?
Yes, sir.
Yes, sir.
So
Okay.
minus p is like this, minus 2/3a v to the power minus 5/3 plus 2/3 b v to the power minus 1/3 t square is equal to what we wrote?
Is equals to minus का.
P.
Hmm?
Minus P.
No, no.
मिडिल माइनस नहीं आएगा ना
du by dv.
So minus
U by
2/3 a v to the power minus 5/3
Minus 2/3 a v to the power
minus 5/3
hmm,
2/3 into b
d plus
2/3 into b
b v to the power
minus 1/3 into t square
into t square.
and then dv.
No, this is du by dv, no?
Yes, yes, yes. Then no dv.
सर जब हम u का डेरिवेटिव लेंगे तो सेकेंड टर्म में माइनस नहीं आएगा ना प्लस 2/3 आएगा ना टर्म में
आपको क्या नजर आ रहा है?
माइनस हमने यहाँ कॉमन लिया है ना 2/3 a v रेज टू माइनस 5/3
रुक जाइए थोड़ा.
सेकेंड टर्म
Wait for some time. So this is minus 2/3 a v to the power this and plus 2 by 3b v to the power b t square.
आ रहा है सर।
ठीक ठीक है सर।
ठीक है ना?
यस
हाँ
सर।
जी।
ओके
सर
So-
आई थिंक कंफ्यूजन वो मैंने भी यही ले लिया था कि आपने लेफ्ट साइड पे du ओवर dv की वैल्यू लिखी है, लेकिन आपने p की वैल्यू लिखी है।
हाँ वो that was just to show you ना that minus p is del u by del v.
हाँ जी, उनको भी वही करना।
Okay ना?
यस सर।
So let us manage with this. So using this, I can write the value of u. U is function of t and v, right? U is function of t and v. Yes or no?
Yes, sir.
यस सर।
So we have to actually write the equation in temperature and volume. तभी तो हमें निकलेगा ना v और t का expression. So let us write this as del u by del v dv plus del u by del t dt. If u is function of t and v, then this is okay.
यस सर।
Yes, sir.
So see what we are going to get. What you will get here, du by dv. Do it quickly. कितना मिलेगा du by dt और du by dv करके?
Minus 2 by 3 a v to the power minus 5 by 3
Hmm.
plus 2 by 3 b v to the power minus 1 by 3 into t square.
And this is du, no?
Yes, sir.
Du is equal to. So what is du is equal to? Check. This will become minus 2 by 3 a v to the power minus 5 by 3 plus 2 by 3 b v to the power minus 1 by 3 t square and dv is equal to how much we will get? Du will be this now. So
sir.
अलग अलग कैलकुलेट कर लो. du by dv अलग से लिख लो. एक एक करके लिखते हैं जरा. Let us,
Sir,
हाँ.
माइनस साइन
minus sign inside the bracket.
इनसाइड
पहले आएगा ब्रैकेट के बाहर
You have
आएगा।
done this du by
Yes, sir. Yes, sir.
यस
du
सर।
by. Okay. So just let me write again. Du is minus p dv. Huh?
Yes, sir.
And this expression we already know, right?
Yes, sir.
Minus p dv already know. And let us get du like this. So how much we are getting? Right hand side we already know. Just tell me this expression.
minus 2 by 3 a v raised to minus 5 by 3
Del v
dv
if you do it with respect to dv, what you will get?
minus 2 by 3
Hmm.
a v raised to power
Hmm.
minus 5 by 3
Hmm.
dv
Hmm.
oh,
No.
plus sorry,
Plus
plus 2 by 3 b
hmm,
v raised to power minus 1 by 3.
dv
T square.
T square.
and t square
T square, yes, T square.
dv plus del u by del t
2 by 3 b
So 2b
4
v
by
to
3.
power 2 by 3 t.
2 by 3
Not 2 by 3.
no sorry
so 2
b v to the power 2 by 3
2
2t
times t.
into dt is equal to minus 2 by 3a v to the power minus 5 by 3 plus 2 by 3 b v to the power minus 1 by 3 t square and dv. Yes or no?
Yes, sir.
माइनस बाहर लेने से ब्रैकेट के अंदर फिर माइनस आएगा ना?
No, minus p dv.
No, sir.
Okay,
Oh, yes sir, yes sir.
Yes, sir.
so now write the equation. What will it become? Take this one to this side and keep it. So this will be b v to the power 2 by 3 dt 2t and dt is equal to. What if we bring this side?
So you
So it is like this,
minus
na?
4 by 3 b v to
Minus
the
and minus. It is like this, na?
Yes, sir.
So this will be cancelled
Yes, sir.
and this will be added. So what it will become? 4 by
Minus 4
3?
by 3. Yes, sir.
Hmm?
Minus 4 by 3.
bv to the power minus 1 by 3 t square and dv. So they have just asked for the proportionality. So just forget about the constants. So dt by t, yes, is equal to, is proportional to dv by what I am getting?
Some v to the power minus 1.
2
by
by 3.
This will come this side. So minus 1 by 3 minus 2 by 3. So minus 1. So dv by v.
Yes, sir.
Sir.
Not correct, na?
2b cancel हो जाएगा.
dv by v. हाँ सही है. dv by v. And what will be here is equal to
2 by 3.
Minus
What?
4
Minus 2 by 3.
Hmm?
Minus 2 by 3.
2 and 2 cancel. Minus b and b
2 by
cancel.
3.
Minus 2 by 3. Integrate it.
sir v raised power 1 by minus 1 by 3.
Log t equal to log v की power minus 3 by 2.
So log t will be minus 2 by 3 log of v plus k,
Yes, sir.
and this will become ln t is equal to ln v to the power minus 2 by 3. Correct?
Yes, sir.
So v to the power minus 2 by 3 is proportional to t. So put here minus 3 by 2. Yes or no? So v is proportional to t to the power minus 3/2. समझ आया?
Yes, sir.
Little
Yes,
bit
sir.
of algebra is required.
सर एक क्वेश्चन था
हम्म।
सर, आपको कैसे पता चला कि मुझे इसको यू टीवी के फंक्शन में du
देखो u is given as a function of t comma v. It is given.
ओके सर,
And pressure is given. And
Yes, sir.
dq is equal to 0 is given. So the first step is that you will write dq is equal to du plus
pdv.
pdv. That means you will get a equation du is equal to minus pdv. The value of p is already given.
Yes, sir.
Now the value of du is to be written.
Yes, sir.
So when the u is function of t comma v, how you will write? What is the method? Only
Right, sir.
differential method is there.
Yes, sir.
Okay. So जैसे
Yes, sir.
ही you will try to write du, there is no other method when it is function of v comma u than this. Only method is this. Got it? Anything else anybody wanted to ask? Okay then. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.